All right, 1.2 random samples to understand, construct, and use simple random samples. Also to be able to state and describe the difference between some of the simple random samples. Okay, again, from yesterday, a sample is a portion of the population. In other words, that is a subset. So let's say a population would be Cheyenne High School. A sample of that might be going to maybe PE classrooms. It's not the entire group, but it's a portion of that. Now, that might not necessarily be a real good sample, but we're trying for a simple random sample. Starting to get into some notation. If you ever see a lowercase n, that's the size of the sample. In order to be a simple random sample, each of the members of the population has an equal chance of being selected. And each sample size has an equal chance of being selected as well. So if I say my sample size for n equals 10, I've got just a chance of getting 10 from here as I do from there, and I'm not really picking out my 10 with an intention. Some simple random sample techniques. We could use a calculator. Simple random sample techniques could be a computer program. For the most part, we're going to use the number generating table or the random number table that I'll show you about here in a little book, in the back of the book here in a little bit. You could pull numbers from a hat, okay, or pull names from a hat or a deck of cards or whatever, just as long as it's simple and random. Some that aren't simple and random, standing in the hallways, asking a student as they walk by. It might be simple, but it's not very random. Putting an ad in the paper and asking for volunteers to take part in your study, or maybe just pulling your classmates that are in this classroom. Yeah, simulation, it's an arithmetic imitation of real phenomenon. So I'm going to the back of the book and I'm looking at this random number table. It's on page A9 of the back of the book. Okay. My random number table is going to help me simulate tossing a balance. In other words, same weight, fair, heads or tails, penny 10 times. So I don't want to hear the clanking or whatever. What I'm going to do is I'm going to establish right away that any even number that I come across in my table is going to represent a heads. So any odd number that I get once I flip is going to represent a tail. Now I'm back at that table in A10. I'm looking at the first row. And I'm going to grab the first 10 numbers, and they're 9, 2, 6, 3, 0, 7, 8, 2, 4, 0. And if you have a question as to how I got those, we could talk about that in class the next day or tomorrow or whenever you can see me again. But this would represent an odd number. So I've got tails. Even, so I've got heads. Even again, so heads, tails, even. So, wrote even, and I was thinking about the number. We're going to go with heads, tails, heads, 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 and heads. So there's 10 flips of a coin without actually flipping the coin. Okay. Do you think we'd get different answers if we picked a different spot on the table? Of course we are. I can go anywhere in the table. I could pick maybe the second row, the last row, the fifth row. It's going to give me different numbers. Okay. Question for you. Again, this works out a little bit better if I were to work within the class, but let's say the class of, I don't know, say 20 students. So every student gets a number 1 through 20. Okay, I'm going to look at the fifth row of the number table. So the first couple numbers I see are 0, 6, 3, 4, 8, 7, 6, 9, 3, 8, and it keeps on going. Now what's going to have to happen, because I have 2-digit numbers, I've got people that are student number 10, 11, 12, 13, all the way up to 20. Those all have 2 digits. I have to pick my students 2 digits at a time. So my first one is a 06. That's going to end up meaning 6. So I just selected student number 6. Okay. I go to 34. Not going to work. There's only 20 people in the class. 34 is out. 87, 69, 38. I still don't have my 3 students, so I'm just going to keep on going until it's finally 3 numbers that fall between 1 and 20. Okay, if you get the idea. Okay. There's stratified sampling. Okay, break all the data into stratas or a common characteristic. The example that I use here is that you split high school students population, everyone in the school, into their strata, which would be freshmen, sophomores, juniors, and seniors. But then once you get there, you're going to ask a sample of each group or from that strata. So only 100 freshmen that question, maybe 50 sophomores, etc. Systematic sampling. Assume the elements are going to happen in some sort of natural numeric order. I'm going to start by asking going through and finding every kth object or whatever. So maybe it's I go to the line of people waiting for a concert to get tickets. I pick a starting point, and from there I pick every 7th person and ask them that question. So I've got some sort of system that I'm using and some sort of starting point to get my sample. Cluster sampling. Begin dividing the population again into sections or clusters. So my example is I went to the high rise and I asked males only at the dorms of NDSU. Those would be my clusters. But this time when I get those clusters, I'm going to go to the 2nd, the 5th, the 6th floor, which are the high rise male only dorms. At least they were when I went there. And I'm going to ask all of them that question. So the difference between strata and cluster is that strata, I break them into groups and ask for samples. Cluster, I break them into groups and I ask everyone, the population of those groups. And then convenience, which is probably the worst one of all. You're going to use some data to just sit back or get data by just sitting back and watching or just letting them come around to you. Very risky. There's a lot of bias involved. For example, if I want to ask a question about Verizon, I ask customers to fill out a customer card. Okay, it's just very convenient. They do all the work, and it's at the place that I'm getting information about anyways. Students walking along the hallways, they just kind of walk by like, hey, kid, want to come over here and answer this question for me? Okay, kind of a really easy way, but not very good way because, again, there's a lot of bias that could take place into that. Think about the hallways. Most of our lockers are grouped by age groups. I'm going to get a lot of the same age groups in my answers, or a lot of Verizon customers in my answers. Okay, so just kind of identifying which sampling group is happening. Students are waiting in line at the bookstore. They pay for their dorm supplies, and every 5th person is asking. This is systematic. And again, because you got some system, you're asking every 5th person. Okay. College students are waiting in line for the bookstores. You're asking them to voluntarily take a survey. Okay, that's convenience. Okay, you're just kind of chilling out, waiting, letting them come to you, or you go right to them, but letting them out. High school is you break your students into every homeroom. Okay, so everyone goes to a homeroom and then are selected to take a survey. Now, you're breaking the entire population Now, if it's in the homeroom and everyone in that homeroom takes the survey, you're looking at if only some of the homeroom take that survey, then you're looking at stratified. Okay, a random generator is used to select the number of or numbers for the state lottery. That is a simulation, kind of like the number generating table in the back of the books. All right, collect opinion from a new registration process. 5 majors are selected, and then a sample from each of those. So keyword there is sampled. They're broken down by those 5 majors, but within them, you've got a sample. So you're dealing with a stratified. Okay. Again, go to the book, practice a couple problems. If you've got any questions in class, I'm more than willing to help you out there.